Thanks for joining to our monthly meetup. So today we have a special guest, Darya. So Darya is an AWS Community Builder, and I'm not going to say much, but I would let Darya tell us who she is. Darya, you can take it away.
Yeah, sure. Thanks, Cyril. Thanks for having me. It's a real pleasure to be here today. I'm joining from Poland, so it's 4 p.m. for me, and it's also a little bit cold. I mean, it's not like in India, yeah, but it's still manageable. So today I'm going to talk about. I will talk about myself a little bit later when I start presenting my topic. Let me just go ahead and share my screen. Uh, okay, so today my topic is about RAG, but cost-effective RAG. You don't need to break the bank, and how to build a Bedrock agent with S3 vector-powered knowledge bases. And I wanted to start with a simple but powerful quote said by Swami, who is VP of AWS Agentic AI. Probably you all know him. So during this summer summit in New York City, he said that vectors are the language of AI. And if you think about it deeply, then we can reason that our large language models are as intelligent, only as good as data it can access. And vectors is how AI understands its data. So it captures context, relationships, meaning. So if we want our agent to remember some past interaction, discover insights from our data set, this is all going to be stored inside vectors. And thus, vectors are becoming strategic assets for, yes, Swami is exceptional, right?
Don't worry about me. We love distracting ourselves in the comment, Darya. Yeah. Okay. Yeah, keep going. Sorry.
I'm keeping an eye on the chat. So today our agenda is to first introduce S3 vectors. Then we will see how it's easy to create a S3 vector index from basically from scratch. Then we will see how to create a Bedrock knowledge base with S3 vectors. And then we will see how to build Bedrock agent with S3 vector powered knowledge base. And then we will see some best practices how to increase the accuracy for your agents. And we will have time for Q&A. I will try to scroll up the chat and see your questions. And you're also welcome to unmute and ask your questions. All right. So a little bit about me. I work as a senior data scientist at a company called SLB. And as Cyril mentioned, I'm AWS Community Builder since 2022. So it's been a while for me. And now I'm in AI engineering category. Previously, I was in machine learning category. I have 7 AWS certifications, and I like to learn and share my knowledge. So let's introduce S3 vectors. Probably some of you already heard about them. Probably some of you already played with them. So essentially, is the first cloud object store with native vector storage and a query support. In a nutshell, if you imagine the elasticity, scale, and durability of Amazon S3, and if you join these qualities of S3 with vectors, you will receive S3 vector storage. And what is also essential, it is up to 90% lower cost for uploading, storing, and querying vectors comparing to OpenSearch serverless. And we will see this later on. I will show you cost breakdown. So this is really cost effective. And because it is that cost effective, we can store large vector databases, basically to keep a memory database for our AI agents. So, and also we can store billions of vectors and receive sub-second query performance. So how does it work in a nutshell? It all starts from our raw documents. So we have some, let's imagine PDF files. We need to split them in other way, chunk them. And then we need to use embedding model to convert these pieces of text to numerical representations, basically to create a vector data. So imagine that we are trying to map each word or each sentence to numerical representation in a vector space. And then we organize this vector data into S3 vector. So it will be stored in a S3 vector bucket. And inside this vector bucket, this data, numerical data, is organized into vector indices. We can have up to 10,000 indices per bucket. And this is our vector storage. And we as users can use this vector storage to perform semantic search via vector index. And I think the terminology can be a little bit overwhelming or misleading. So let's try to break this down because we already mentioned vectors, vector indices, and vector buckets. So the first key or big umbrella term is a vector bucket. Imagine just a simple S3 bucket and imagine that is suitable for storing vectors. Bingo, you have vector bucket. So this is a new bucket type that is purpose-built to store and query vectors. And inside vector buckets, we can have vector indices. And you will perform similarity queries on your vector data within those vector indices. And inside these vector indices lives your vectors. Like here, you can see, we can have many of them, but this is just an image. And for AI and similarity search, those vectors are created as embeddings, basically numerical representations that captures semantic relationship between your content, like text or images or audio. And what does it mean semantic? It means that similar items, semantically similar items will be placed together, and we can search by meaning rather than by exact match. And also each vector can have a metadata, for example, some timestamps, some attributes to support filtered queries. But we will talk about metadata a little bit later. What is also nice that S3 vectors are pretty new, but they're already nicely natively integrated with some of AWS services, namely with Amazon Bedrock knowledge bases and with SageMaker Unified Studio. So you can power cost-effective RAG applications. And also, it is integrated with Amazon OpenSearch service. This is kind of interesting because you can think about S3 vectors as being a replacement or like an alternative to Amazon OpenSearch service. But in reality, you can pair up to create tire vectors. So you can keep rarely queried data in S3 vectors to make it cost effective. And you can move to OpenSearch service for real-time, low-latency search when needed. So it's like a combination of two. It's also possible. And I mentioned in the beginning that S3 vectors are cost-effective. And now let's see why. And this table is a little bit big, but I will walk you through. When we compare Amazon OpenSearch serverless with Amazon S3 vectors, the key difference is cost structure. As you can see, for Amazon OpenSearch serverless, you will be charged based on OCUs. It's basically a compute unit that bundles CPU, memory, and storage. It means that you will pay a fixed cost payment per month, even if you don't touch your vector storage. And if you consume like a bare minimum one ECU, you will be charged approximately $174 per month. And it can easily go up to 350 and more per month, even if you don't consume anything. But with Amazon S3 vectors, there is no baseline basically. You pay for only what you use. You can pay for storage for just like 6 cents per gigabyte per month. Also, there is 20 cents per gigabyte for put requests. Also, just a fraction of cent per 1,000 requests for query, and just a tiny cost per data processing. And yeah, you can see that there is no fixing cost. You just pay as you go, pay for only what you use. So the key takeaway, if you have some workloads that don't require constant real-time vector search, like batch similarity queries, long-term vector archives, S3 vectors give you massive cost saving without provisioning infrastructure upfront. Yeah, it is. It is more serverless and OpenSearch serverless. Yeah, we can call it in that way. So we kind of introduced S3 vectors, and now we'll see how to easily create S3 vector index from scratch. What you can do, I like doing things in the console because you have a visual representation of what's going on. And yeah, the place to find S3 vectors is Amazon S3. You just need to find vector buckets in the left navigation pane, and then choose create vector bucket. Pretty the same thing as you're creating an ordinary S3 bucket. You need to enter bucket name and choose encryption type. If you don't specify an encryption type, Amazon S3 will apply automatically server-side encryption with Amazon S3 managed keys. It will be base level of encryption for new vectors, but you can also specify your other ways of encryption, like using key management service. So you gave a bucket a name, and your bucket is created, just as simple as this. And then remember my picture, inside the bucket, you can create a vector index to store and query your vector data. To create a vector index, you just click create, enter your vector index name. It can be pretty simple, as you can see. Then you need to enter the dimensionality of the vectors. So all vectors that will be added to this index must have exactly the same number of values, exactly the same dimension. And then you have a distance metric, whether cosine or Euclidean. You need to select your embedded model's recommended distance metric for more accurate results. And then you choose create vector index, and then you can insert list and query vector indices. Okay, you successfully created vector index, and it is here. You can see it in your inside your S3 vector bucket. And the next step would be insert your vector embeddings to your vector index. And you cannot do it from the console. You need to use the AWS command line interface, CLI, or AWS SDK, or Amazon S3 REST API. And to generate vector embeddings for your unstructured data, you can use, for example, Bedrock models, right? Your code may look like that if you're using the latest AWS Python SDK. In my example, I truncated text here, but in the actual code, you have like full sentences. These are just information about AWS Community Programs for AWS Community Builders Program and Cloud Club Captains Program. So I have 1, 2, 3, 4, 5, 6 pieces of text to be embedded. And then I'm just using Python embedding model version 2, and I'm embedding those pieces of text. And then I'm inserting these embeddings into my vector index. And you can see I'm putting along with my vector, I'm putting some metadata and some values for this metadata. For example, here I have attribute like program, and I am tagging each sentence with a corresponding program. For example, this sentence was about community builders. This was also about community builders. And then I have some sentences about Cloud Club Captains Program. So they are inserted. And now I want to know what are the program benefits. And you can see that my question is a program agnostic. I can ask about any program. And to query my vectors, I need to first transform this sentence. Again, using the same embedding model, I'm transforming this question into embeddings. And then I am basically querying my saved vectors. And you can see that I'm doing the filtering with the metadata. For this example, I want only to include results about Cloud Club captains. And for another example, I would like to know about community builders. And let me show you how it looked like in a real life. I would say from my code idea. This is PyCharm. The code is basically the same as you saw on my slides, except that I have like long sentences here. And yeah, I was doing embedding, I was inserting them, and this is a question. So if I run this code, I have basically two times I'm querying my vectors. The first is about Cloud Club Captains Program. What are the benefits of this program? And the second would be about Community Builders Program. So I'm doing this search 2 times. And you can see that I have like basically 2 responses here. The first one, these are returned vectors, and it is all about Cloud Club Captains. And I can see the information. I have a source text here. I have this metadata attribute. I have ID, and I have some distance or relevance to my query. And I have, again, another sentence, and I have distance here. Probably it is more relevant to my question. And I have this tag about Cloud Club. And the second time I was asking about community builders, and I have all sentences about community builders program. This is the first one. Oh, we have credits, we have learning, and so on and so forth. And here we have some description of the program, and we have tag for community builders. So you can see that even with a simple example, we already can do some metadata filtering, and we already can increase the relevance of our results. Okay, let's move forward. And if you like command line interface tools, I also found this repo S3 Vectors Embed CLI. This is for creating vector embeddings for your data using Amazon Bedrock for storing and querying them in an S3 vector indices using single commands. So it worth to know that document chunking is not currently supported, so you need to pre-chunk your documents, but you can create vector embeddings, you can ingest them, and you can perform queries using this tool. Maybe it would be interesting for you to check. So now we talked about how to create a vector index, how to query it, and now let's talk about how to create a Bedrock knowledge base with S3 vectors. Because the integration is already there and it's very simple to do this, we just need to follow simple steps, simple general steps of a Bedrock knowledge base creation. If we go to Amazon Bedrock console, we go to Builder Tools, Knowledge Bases from the navigation pane, and then we will create knowledge base with a vector store. Pretty simple. And then we need to provide knowledge base details, its name, description, permissions. In this example, we will use Amazon S3 as our raw data source, but you can also have your custom data, crawl some data from web, and you have a lot of options here. And then you specify data source. You need to configure this data source. So you need to provide its name, location, this AWS account or another AWS account, S3 URI, basically S3 address, and then parsing strategy and a chunking strategy. But we will talk about those strategies later on. And then you need to specify embedding model and vector database, Amazon S3 vectors. You can see here it's currently in preview. Next, you just review all your settings, you create knowledge base, and all you need to do is to synchronize data sources. So you basically have this GIF here. It is turning state from synchronization to fully synchronized. This is important because otherwise you just cannot access your information if your data is not synchronized. And that's basically it. You already created your knowledge base. And the next, and I would say the most important step is to test your knowledge base, because we would say like garbage in, garbage out. If your knowledge base information retrieval is not going smoothly, you cannot rely on the answers of your agent, right? So you can basically have two modes of testing. You can have retrieval only, or you can have retrieval and response generation. What does it mean? When you ask your question, for example, you want to know like a specific year when some event was happened, and you know that this information should be inside your documents, you can, with retrieval only, you will see only the pieces of document that were extracted, like original information that was retrieved. But with retrieval and response generation, you will see a nicely formed answer based on the retrieved responses. So it's very good to have an understanding of what are original pieces, what pieces are retrieved, and also how the model will tackle them, will understand them. And you also can play with a number of source chunk. Default is 5, but it can be up to 100. It's also a question of relevance and model being able to process so many retrieved chunks. So, and how the testing looks like, you can see that my testing here is was to extract only, no, it was a generation of response based on my context. And you can see that that by giving your response, you will have a source, like link to the source document. Maybe it's not pretty here, but you can see this like little number 1, and you can basically click on the link and you can see the original document, which is very good for the traceability, so you can understand what is going on. And by the way, my question was about GraphRag, and these are documents that contain the information about GraphRag. In that example, and you will see a little bit later, I was using some documents about agentic AI, about GraphRag, and also agent-to-agent protocol. So I just wanted to dump some, research documents from AWS and other papers to understand more about agentic AI. Basically, to build a research paper reading helper. Now we have a knowledge base, and it takes only like a few minutes to build a Bedrock agent with this knowledge base. Okay, so the architecture will be pretty simple. We have our user here who will be interacting with our Bedrock agent. We will have connected knowledge base that we created in a previous step. And that knowledge base will will search, perform the search on S3 vectors, and our raw data lives in a structured S3 bucket. So pretty simple. To create a Bedrock agent, we need to go to Bedrock console, choose Builder Tools Agents, and click Create Agent. You need to provide your agent a name, optionally some description, and just click Create. And after that, you will be redirected to Agent Builder. You will need to select a model, a resource role, and specify some instructions. And if you want to, provide additional settings. Why instructions is yellow here, you can see from the message that in order to optimize agent performance, in some cases like ours, we have very simple architecture of Bedrock agent. We will have only one knowledge base. So the agent will ignore your instructions. So you can think, okay, if it will ignore my instructions, I can provide no instructions. But no, you cannot provide no instructions. You need to provide at least some instructions, because otherwise your agent creation will fail. So it's just nice to know about this. So, but you can see that the instruction can be just a one sentence that you are intelligent and you can use this knowledge base to answer my questions. So yes, we provided instructions, and then in our agent builder, we can scroll down to the section with knowledge bases and click Add Knowledge Base and specify our knowledge base that we already created in the previous step. And you can, this is also, I think, optional to provide some instructions when to use this knowledge base. But it's no harm to specify those instructions here, because agents can understand the boundaries of its knowledge. And then when you save it, when you add the knowledge base, you save it in the agent builder. You need to prepare the agent, otherwise it won't be able to find the knowledge base and react to your latest changes. So the next step is, a long step is testing and tracing. I was asking, for example, how to build a basic reasoning agent. So in my opinion, my Bedrock agent should go to the knowledge base, should search for relevant pieces, and to give me a good comprehensive answer. And how do I know if it was from the knowledge base, I can see that there are a number of sources or links in the agent response, and I can go and check the original document. And additionally, in a tracing, I can scroll through the steps and I can see here I had invocation type knowledge base, and I can see what was passed as a question to the knowledge base, and I can see what pieces were retrieved. So it's good for traceability and observability of what was going on behind the scenes. And this part will be about, so we just did like a plain vanilla Bedrock agent with a plain knowledge base, but there are also some techniques to increase the accuracy of agent response when we are working with parsing, chunking, and metadata filtering strategies. If you remember, when we were creating the knowledge base, there was an option to specify parsing strategy. So there is a default Bedrock default parser, which comes with no cost, non-additional cost. And also we have Bedrock Data Automation as a parser and a foundation model as a parser. Let's find out why we should consider those two options and when, because they cost additional money, and we should be aware why we should use them and when. So the first, this is like a comparison table. And the trade-off is about what we want to achieve. If we want to have like ready to go automatic information, automatic data parsing, maybe Bedrock Data Automation would be better choice. You don't need to provide any additional prompting. You just can use it to augment your data. So if your data contains images, tables, some rich information, which is not text, that will be ignored by Bedrock default data parser. But with those two guys, with Bedrock Data Automation and with Foundation Model, it will be able to parse this data like images. Yeah, and if images are crucial to you, then you may consider pen additionally to have this information incorporated. But Bedrock Data Automation will do it in a more like automated way, but Foundation Model will do it in a more customizable way. And also cost is something you may want to consider. Bedrock Data Automation is more predictable because you're paying for number of pages in the document or number of images to be processed, or per fraction of time for audio or for video. For example, you're only paying 1 cent per page for US East 2 for data processing. But for foundation model, you will pay dependent on the number of input and output tokens processed by the foundation model. So it will depend on your prompt. It will depend on the output as well. So it's a little bit unpredictable. And very important disclaimer, if you choose for your data source Amazon Bedrock Data Automation or Foundation Model as a parser, this method will be used to parse all PDF files in your data source, even if some pages contain only text. And this is something to be aware of, because if you have, let's say, tens of thousands PDF pages saved in your storage, and only like a fraction of them contain images, then probably you would like to, I don't know, maybe split them, or just to be aware of those costs, because all of these pages would be processed by the indicated method. So I decided to test it, whether it worth the money, whether it worth additional hassle. And you can see the page of my original document. This is the research page, and I found interesting image graph here and a number of publications of graph racks in different domains based on a number of papers. And the graph is pretty simple, but if I use for my person just default Bedrock person without data automation, I'm asking how many publications of graph racks are in the knowledge domain. You can see knowledge domain here. And my agent didn't know about anything. So this information, this image was just skipped. It wasn't processed. So this data was just blank. And if I also tried Bedrock data automation, and I asked pretty much the same question, and I received the answer that there are 48 publications in the knowledge domain. I don't know if you can see it, but there is indeed 48 publications. And how do I know that there is not like wild guess? I can see what was going on, what was retrieved, and I can see that Bedrock data automation generated a nice description of my image. Figure number 2, publication of graph rack in different blah, blah, blah domains. And you can see that it was basically describing what was on the image, and it was putting the numbers 48, 35, 23, and 1. So it was describing my image in a very descriptive way. And that's why it was able to answer my question. So you may wonder how to decide with the parsing strategy. The first question you need to ask yourself, is your data purely textual, or it contains important multimodal data you want to be processed? If it's purely textual, you can go with default option. If it's multimodal, you want to have this information included, then you need to think whether Bedrock data automation with a foundation model as a parser. The second question is, how much do you want to customize the prompt that is used to instruct the model? If you don't want to have any customization, you just want a quick automatic solution, this is Bedrock data automation. If you want to customize, this is foundation model. Pricing, do you like to be priced per page, or this is Bedrock data automation, or per token, per number of tokens? This is foundation model. And finally, if you have files greater than which size is greater than 100 megabytes, then foundation model cannot process them, then Bedrock data automation is your choice. So the next strategy is chunking. You can see that when you're creating your data source, you have different options of chunking. The first one is default, is approximately 300 tokens per chunk with respect of word boundaries. Then you have fixed size chunking, when you can specify your custom number of tokens plus some overlaps. Then you have no chunking option. It's here. If your files are already pre-processed and you don't need to split them further away. Also, you have an option to do hierarchical chunking. It will organize your data into parent and child chunks, and retrieval will bring child chunks. It will start with child chunks, but will return parent chunks for like broader context. And finally, you have semantic chunking, which will split your data based on the semantic content, and you can tune some parameters to balance with the context and I would say precision of your data. But this option also includes some additional cost because foundation model will be used in semantic chunking. But you can think about, so you can go, if you first trying to create your Bedrock knowledge base, you can go with the first and default chunking, which I did in my example. But if you want to be like more specific, or if you know your data very well and you understand the way precisely you want to have it basically split or chunked, then you need to think about different ways of doing the custom chunking. So consider this example. I have a legal document and I need it to be chunked by this like red rectangles. And you can see that they are not even. Yeah, their size can vary, and we cannot rely on the like default chunking in that case. Also, semantic chunking, I'm not sure whether it will work as we want it to work. So in that way, we can select a non-chunking option and use a custom transformation lambda function, which will provide a specific custom chunking logic. For example, use a regex to specify each clause or each paragraph with a number should be considered as a separate chunk. So Lambda will split the documents and will return chunked files via S3. So this is also possible if you need such level of customization. And finally, we can talk about metadata. You already saw an example how metadata helped me to basically filter out the results which are relevant to a specific program, yeah, for community builders and cloud club captains. But for vectors, we can have filterable metadata and non-filterable metadata. And you may wonder why we would have a non-filterable metadata, because we cannot filter by this metadata, why it exists. So the answer is pretty simple, because let's start with the filterable metadata. Filterable metadata is a key value parse that I use to filter query results, as you saw. For example, we can have a program or genre or year or price, something like that, some attributes you can think of. And the type can be string, number, boolean, or list. And non-filterable metadata, it is non-searchable, but it can store larger context. For example, full text or image description. And it is good to have it for like general traceability. And it is returned with query results. So you can quickly understand like the broader context of this vector. And another thing I wanted to tell you about metadata is that you can have multiple conditions and you can combine them on the same field or on different fields. So let's say I want to find a book, which would be like in a specific genre, and a price between greater than 10 but less than 50. So this is also possible, and we can have like very like specified and alone expression with metadata filtering, which can increase the accuracy of the result that we return. And finally, I wanted to say like a couple of consideration and limitations you need to keep in mind. S3 vectors are still in preview. So some things can be changed until they are generally available. Currently, they are available in 5 AWS regions. The limits are 10,000 vector buckets per region, 10,000 vector indices per vector bucket, and up to 50 million vectors per vector index, and up to 10 metadata keys per vector, total metadata keys, and up to 10 non-filterable metadata keys per vector index. So let's see how it will go when they become generally available, but this is the current state. And if you are curious and want to explore something next, if your Bedrock agent is already ready, you are happy with it, you can migrate it to Bedrock Agent Core. If you want to go beyond AWS config only setup and turn your agent into real code to get more flexibility and add some enterprise features like memory and make it production ready. Also, I found very interesting example how to use S3 vectors to do a semantic search on your data lake. You can dump like images, videos, and just type some key phrases and search on your media lake. And also, I was talking about this in the beginning, how you can integrate and combine S3 vectors and Amazon OpenSearch service to bring cost effectiveness and query performance at the same time. And that leads us to key takeaways. The first one, as I said in the beginning, Amazon S3 vectors is the first cloud object store with native vector storage and a query support. Think about scalability, durability of S3 and combine it with vectors. They already can be nicely integrated with Bedrock knowledge bases, OpenSearch servers, SageMaking Unified Studio. And finally, you can use them to build semantic search and RAG systems without spending a fortune, and it's relatively easy to do it. So with that, thank you very much. Let me see what we have in chat, because for some time I had to ignore all the messages.
Yeah, thanks so much. Thanks, Daria. This is really very interesting. Now we can have our own vector store directly in AWS. For the Pinecone users, I hope you guys will stop using Pinecone. I hope you guys will just stop using Pinecone. So yes, we have some very interesting questions. So one of the questions what Foster asked was would like to know real use cases where S3 vector is suitable and where they are not. Yeah, compared to AWS has so many services. So when do we use them? S3 vector.
So I would say if you want to store a lot of historical context for your agents, and you really don't need to be them like sub-second performance to have sub-second latency. Yeah, you can allow your agent to think a little bit. Then S3 vectors are good because they are cost effective. And let me just go back to that slide where I was showing, it was in the beginning, when I was talking about OpenSearch service. Yeah, OpenSearch serverless is good for real-time, low latency search when needed. So it's dependent on your use case, but also I was talking about pricing, that OpenSearch serverless has a minimum value you should spend per month, and it's like if you are doing like your own project or your company is very looking for a cost-effective solution, so OpenSearch serverless may not be like a suitable choice for that case. Okay, let me know if it helpful.
Yes. So yeah, there's also a follow-up question. Say from Foster that how do we ensure the response from the agent is good and based on knowledge, based on coming from the knowledge base.
Yeah, so happily we have traceability in our Bedrock agent, so we can see what was the source of the document, or we can click on that number and see what original document it is referring. But we can also we can also like ignore the agent step. Yeah, we can test for the knowledge base to have the number of the answers and test whether the retrieval is good and in our opinion relevant. But from the agent, yeah, it's also like the same approach. Uh, give give questions, see the answers, see what was going on in the steps when we can trace the answers from the agent, see whether the call to knowledge base was executed, see what kind of pieces of documents were returned, and see what was the final response formed by the agent. But yeah, I think it's more like a general answer. I think it also will depend on the criticality of the information, because you may be perfectly fine when the agent, I don't know, forget about like one item out of 10, but for some responses, it should be really like strict. And I think you need to prioritize, give the higher priority, yeah,
Prioritize.
to sure, give the like higher priority for those like strict question answers.
I do have a question.
Yeah, sure.
Yeah.
Go on.
Okay. Assuming I'm building like a RAG app where I'm hosting my app separately, my LLM, I'm collecting my LLM by like an API, all of these non-AWS. Now, can I use S3 vector the same way I would like use a quadrant or pinecone where my LLM is configured to use that as its knowledge base, where I'm just using the same way I would use pinecone. You understand? Like I'm removing pinecone from the equation or quadrant, and I'm plugging the S3 vector, let me say API, without every other thing being on Amazon.
I think it is possible. I didn't test it, like to use it outside AWS, but it is
You know, the
interesting
same way we can
question.
use S3 outside AWS. Like I could have my application running on some server where all the pictures people are uploading is going to S3. You understand? So since I'm just assuming, since S3 can be used outside of my whole application, does not have to be on AWS for me to use S3. So I was hoping maybe we could use this too without having to be on AWS. I'm sure that's most people use S3 are not even on AWS. You understand? So
Yeah, but I don't think I don't see why not.
okay.
Like if we can use S3 as external, like outside of AWS, yeah, or we can call it as API. So the whole concept of AWS as API is as a service. So I don't see why it's not possible.
Okay, I will research it. Yeah. Okay, cool.
Nice. Okay, should we move to the next question? Okay, can Amazon Bedrock automation can be used in complex document extraction for tax regulation document or account open and paperwork? Bedrock data automation, complex document. So the information from the complex document, yeah, I think so. Account open and paperwork. So the purpose of Bedrock automation is to augment your documents, so it can describe what is on your documents, but it cannot help much like in doing the paperwork or something like that. So it can only like describe your form, tax form or something like that. What is being going on the page. Maybe it can be misleaded if the table is too complicated, have a lot of rows, like merged columns, merged rows. Maybe it can miss something. But yeah, I think it could describe what is on the page.
Okay.
Yeah.
Yeah, and
Yeah.
thank you for your answer. I was looking for like I was comparing this product with another product. Basically, I don't know if you if you heard of it. It's called
Mm-hmm.
Landing AI. It's also for some product that is kind of similar, that
Mm-hmm.
you can kind of like present the document, and he will be able to describe, locate the position of the amount, even tell the information of the client, for example, last name, the addresses. If there are
Mm-hmm. Mm-hmm.
complex table, if there are complex table, also it will be able to locate that information. So I was looking
Mm-hmm.
like, there are some financial process that we do a lot of paperwork and required to do some document extraction. Uh, do you think this product is really mature to resolve those kind of problem in the financial sector, for example?
Mm. Okay, so I think you don't need to use because Bedrock data automation is when you're trying to basically describe your data for agents. Yeah, but if you just need to analyze the tax form or some financial documents, there is a service that's called Amazon Textract, and this also works as an API. You just can upload your document, or you can just submit your document to an API, and it will recognize the form. And it's what is good that is this service was tested for mainly, I would say, for US documents. So I think tax form it's pretty, I would say, standard, so it can understand. Uh, so you can try Textract. Like, let me type it. Textract.
By the way,
You can.
this is also for an agent, because at the end we are planning to get this information and kind of like let the agent to analyze the information and take the decision. Could be decision
Mhm,
like, okay, this person is maybe a person that is having financial problems or something like that, So, or maybe
okay.
the income of this person is too low for for providing a credit card. But there are complex documents. I was wondering if Amazon does provide those capabilities already for those kind of documents. And I think you mentioned few of them. I just need to take a look. Yeah,
Hmm.
thank you.
Yeah, but yeah, I think the documents could be pre-processed by Textract, and then this information can be passed to a foundation model, something like that.
Exactly, exactly.
Mm. Okay. Thank you.
Yeah, thanks. Yeah, thanks, Foster. Thanks for your questions. Yeah, so we have any other question here? I know I really like I'm seeing I was using the default vector store created by AWS knowledge bases and didn't find it to be a good option. Have you found the S3 vectors to be better by chance?
Okay, but yeah, Amelia left. Yeah, but I think she was talking about OpenSearch serverless because it was default previously. I think she was talking about that.
Okay.
I need to double check it with her which one she's referring to be default one.
Daryl has a question here. Have you
Mhm.
used other vector stores like Pinecone or ChromaDB? And if so, how do they compare to native AWS options like the S3 vector store?
I haven't compared them yet. Yeah, but it's a good idea. Thanks, Daryl. Yeah, I haven't compared them yet.
Okay, yeah, I think one major
Really.
just be cloud native. That's the first thing, and it can easily integrate to other services, Daryl, because it's AWS native. Yeah, I think that's one major thing if you want to keep everything in AWS. But I love Pinecone, but I would see about this S3 vector. It looks interesting as well if you want to be cloud native. Okay. Okay, so it's interesting.
What
We
do we have?
Okay, one additional comment about Textract. I'm loving it so far, but it seems to have a limitation. Okay, so we have lots of interesting discussions here, and Daria, could you just drop your LinkedIn. I think people might want to reach out to you with more questions or for more.
Yeah, sure.
Yes, can you
Let
just
me do it.
drop it here? I know it's part of the links I added in the meetup, but remember we have this meetup once every month, hopefully the second Saturday of the month. So that is something we hope to meet often. We are very grateful Darya has shared us the knowledge about the stream vector. So I mean, I'm really excited and I want to try it as well soon. So I know Daryl is hoping to meet up with some of the people on the chat at reInvent. Yes, Daryl will be there at reInvent. So is there anybody in this chat who will be at reInvent? End of this year, end of year, we could meet. So it's good to meet. Daria, I know you'll be going to reInvent, right?
No, not for this year, unfortunately.
Okay, no problem. Yeah, anybody else going to reInvent? Yeah. So thanks so much, Daria. Thanks everyone for joining. It's been a very wonderful session. I am very happy. I think let's all give Daria some emoji, some thank you, some claps, because it was a very rich session. If we have anything, reach out to Daria. Thanks for sharing your link. Thanks for always sharing to the community. Thank you all. And
thank you, everyone.
Have a good day.
yeah. Okay. Bye-bye.